Assalamualaikum and a very good morning to my three panels, Prof. Madia Dr. Jaria, Dr. Khairul Fadli, and Puan Adibah Hanim. My name is Mohamad Al-Haziq. Today, I would like to present about my Bachelor degree Project 1 in the topic of nickel-chromium electrodeposition in deep eutectic solvent on steel substrate surface properties and its deposition mechanisms. I am doing my research under the supervision of Dr. Muhammad Zaini bin Zainal Abidin. For the introduction, nickel-chromium alloy is a combination between the nickel elements and also the chromium elements to produce a material of high corrosion and oxidation resistant. This material have been widely used in many fields such as aerospace, military, and also the oil and gas industries due to its unique chemical and mechanical properties. Based on the high demands of the materials, the electrodeposition method can be an alternative way to overcome the constraint of conventional methods, which requires lots of time to produce. Through this method, the nickel-chromium alloy can be produced of greater coating by using a deep eutectic solvent solution that determines a stronger interaction between involving elements. Okay, for the problem statement part, in previous practice, nickel-chromium alloy has been produced by applying the conventional process, the powder metallurgy method, which requires a lot of time to complete. In order to solve the problems, the electrodeposition process has been designed to replace the previous practice. In the earlier research, the mechanism of deposition has been studied using the cyclic voltammetry measurements that required an investigation of the effects of the current density, liquid bath composition, and effective temperature for applying nickel-chromium alloy coatings. The other problem is the ratio of deep eutectic solution and the arrangement of material element on electrode must be determined to avoid any confusion resulting from the investigation. Okay, for the objective part, this research is eventually to investigate the relationship between the current density on the nickel-chromium alloy coating analysis, and the other objective is the purpose to investigate the relationship between the temperature and also the effect of thickness on the nickel-chromium alloys coating analysis. Okay, we continue the presentation on the literature review. Literature review is a part where the findings of information is collect from the earlier journal and research from the other authors. Okay, this part where we define about the what is electrodeposition is about and the solution that we use in the electrodeposition method. Okay, basically the electrodeposition is a process that use the electrical current to reduce the dissolved metal cation so that form the coherent thin coating on the electrode. Okay, this process is involve the positively metal ion from the solution and deposited on the surface of the object connected to the negatively charged electrode named as cathode by passage current electric current. Okay, for the DS solution, DS solution is stand for deep eutectic solvent, which is an ionic solvent that have a high solubility of linen, low cost, and also have high recyclability. Okay, we continue. The electroplating parameters must be controlled during electrodeposition since they have significant effect on the coating properties, deposition efficiency, and hydrogen evolution. Besides the current density and bath temperature, there are more parameters including the pH of the bath, the types, the size, the concentration of the particles, and also the addition of subtectants. Okay, what we can see on the screen is there is a table which have list out the reference source from several journals, and also the current densities and temperature. What we can see is each journals have a different current density and temperature and different from the others. For example, for the Moniruzzaman et al. On the 2012 journals, there are 4 current density is used and only 1 temperature. For the Shinoy and Gowri on 1972 journal, in the experiment, they use the range of 3.1 until 31 current density and 20 to 60 temperature. What we can conclude is different current densities and temperature used for the electrodeposition method have a different experiment result. Okay, for the last part of my presentation, methodology, okay, I will explain about what step I have planned to execute my experiment regarding to the topic of nickel chromium alloy deposition. Okay, we go to the flowchart. The flowchart is described about what step I will be done to execute my experiment. Okay, the first step is electrolyte preparation. Okay, the electrolyte preparation, I choose the graphite and steel plate or ITO as the anode and cathode. Okay, the next step is the substrate preparation. Substrate preparation is actually the deep EUTECTIC solvent solution, which is contain the ethylene glycol EG and also the kaolin chloride CHCl. And then we go to the electrodeposition method. Okay, for this step, I need to activate the DES solution at the temperature of 80 degrees Celsius, which cannot be measured by the potential state, galvanostate, and its reference electrodes. Okay, the DES solution is a mix of ethylene glycol and also the kaolin chloride with a ratio of 2 to 1 at 90 degrees Celsius for 10 minutes. Okay, then the nickel and chromium salt are added to add the various concentration in the DES solution at the 100 degrees Celsius to remove the water content. Okay, then the deposition is done on the 80 degrees Celsius with a various current density between the 10 milliampere to the 200 milliampere for 30 minutes duration to observe the changes of the plating bath color changes. And then we proceed to the analysis, which is SRD and the SEM analysis. And then we get the data, we collect it, and then we go to the result and discussion. Okay, for the sample test, I have choose the scanning electron microscope SEM analysis and also the X-ray powder diffraction analysis SRD. Okay, the SEM is used to observe the surface morphology of the microstructure. It also can able to reveal the detailed surface characteristic of the specimen. It also can provide the information in 3D structure. Okay, for the SRD analysis, it is to use as to analyze phase structure composition of the coating layer. It also able to identify the crystalline phase present in the specimen. It also can reveal the chemical composition of the information. Thank you.